Okay, so we're on part three. Part three, we're comparing rates of change and understanding linear relationships. So the key concept here is that the rate of change tells us how quickly quantity changes in relationship to the quantities change in relation to one another. Okay, a linear relationship can find and compare rates over different intervals. So once you piece it together, that's telling the whole story, right? One linear part could just be a piece of the story. So what we're going to start here is with the first example. So at your table, you're going to analyze this car as it's traveling over a period of time. This car is approaching traffic. Okay. How do I know it's approaching traffic? Because what do you notice is happening? Okay. Now, as you're doing this, I want to make sure that you're comfortable doing this. Notice that I have already given you your rate. Your job is to make sure that you are comfortable finding it. Does that make sense? It has already been given to you. Your job is to make sure that you understand how we got it. All right. So we're going to start here, and I'm going to give you is 2 minutes fair? I think 2 minutes is fair to find all three, to confirm that the rates that you see are correct. Does that make sense? 2 minutes is fair. And go. All right, so let's talk about what you did. So getting to the answer. Remember, you already have the answer. Your job was to make sure that you understood how we got there. So when I have 0 to 2, I'm looking from 0 to 2, right? So I'm using this point and this point to determine my change in my y over my change in my x. Make sense? So for 0 to 2, my change in my y over my change in my x, I went from 0 to 60 on the y, and then I went from 0 to 2 on the x, which is why it said it was 30 miles per hour. Capiche? Okay. Our next interval that you should have had was from 2 to 4. So again, we're going from 2 to 4. So we're using this point and this point. Okay. So you're asking yourself, how did my y change? What's the change in my y over the change in my x? The change in my y, I went from 60 to 100, which is 40. I then went from 2 to 4, which is 2, which is why it said 20 miles per hour. Okay. And then our last one was from 4 to 6. So from 4 to 6. So we're using this point, and we're analyzing how did it change. So your change in y over change in x equals my change in y. I went from 100 to 120, which is 20. And then my change in my x is from 4 to 6, which is 2, which puts us at 10 miles per hour. Yes? So we got this. Okay? All right. Just a last minute check to make sure we're good. I'm going to give you 3 minutes to do part A and part B. So you're going to find the rates of change completely on your own. You are going to do a little guesstimation of the points. Okay? So using a little bit of math sense, you will guesstimate roughly where the points are. I would say keep it easy for yourself, but you should be able to do part A and part B completely on your own. All right, so I'm going to start, and hopefully by the time I get to where other people are, we're all good. All right, so here, calculating the rate of change. So from 6 to 10, again, remember, your interval is describing your x values, right? Where you're going on the x's. So I'm going from 6 to 10. And so for 10, we would just be making a little guesstimation, okay? At 10, I would probably say 74.5, you know? You could have said something else, but you could have said 75 and call it a day, as long as you understand the process. Does that make sense? Okay. So if you were me and you chose 74.5, the difference between 65 and 74.5 is, anyone choose it? 9.5. Okay. So my rate of change would equal 9.5 divided by 2, 4. Because my change in my x. And that's a number right there. Yep. 9.5 divided by 4 is 2. Yeah, that was like 2.375. And that's going to give you your units. So our units this time, our Y is our Fahrenheit and our X is our hour, right? So 2.375 degrees Fahrenheit per hour. Okay. Make sure you're putting those units. All right. Next, our rate of change for the next one. We're going from 10 to 12. So again, looking at the X's from 10 to 12. So here's 10. Here's 12. 12 is at 80. So from 74.5 to 80 is going to give me 5.5. And then from 10 to 12 is going to give me 2. And I divide that in half and I get anybody? 2.75 degrees Fahrenheit per hour. Okay. From 12 to 15. So now we're going from 12, which is at 80, to 15. Pretend that's a straight line.